Chapter 30, Air Brake Foundation Systems and Air Brake Circuits, Day 3, Video 2, Spring Brake Chamber. Okay, from the last video, we were talking about a service brake chamber. Okay, so the difference between our service brakes and our park/emergency brake system is the service brakes are those normal brake applications. We're driving down the road and we need to slow down. We push down on the brake pedal on the treadle valve and it opens. We send air pressure out. That is our service brakes, right? Routine slowing and stopping of the truck. So the park/emergency brake system, we have that is used to hold the truck once we've stopped. We can release the service brakes, but now we've got the park brake that's holding the truck from moving, right? That's the park brake function. And then the emergency brake function would be we have a failure in the service brake delivery side. We have no service brakes. We can use the park emergency brake system to stop the truck, right? So one of the key components to that we really have to understand is when we are making a service brake application, okay, we add air pressure to the brake chamber to apply the service brakes, right? We're using compressed air as the energy source to apply the service brakes, right? Our park and emergency brake system has to be applied by a completely different energy source, right? Federal law FMVSS 121 dictates that we have a separate energy source to apply the park emergency brake. If we have a failure in our air brake system, the compressing the air, we're no longer able to store the air, we need to have a secondary energy source to apply the brakes for safety reasons, and we use a spring to do that, right? So the energy stored in spring to apply our park and emergency brake. So both of those chambers can be the park and the service brake chamber combined in one component. So we'll call that a two-chamber or a dual chamber brake end or brake chamber. So again, looking at the principles of pneumatic, does not matter if we're using air pressure, hydraulic pressure in here, working against this surface of this piston we would have the rod here coming through our brake chamber to our S-cam. If we're using what energy source we're using, compressed air, pressurized fluid, or in this case, in our spring brakes, the energy of that compressed spring working against this piston that would then have the push rod connected to that would actuate the brakes. Separate energy source. So looking at a cutaway of a dual brake chamber, the chamber that is closest to the slack adjuster, right here with this clevis that hooks into the slack adjuster, this chamber right here would be our service brake chamber, right? 30 square inches, the air pressure comes in, trapped behind that diaphragm, and the pressure plate, the push plate, pushes that piston down, applies the service brakes. The second half of this brake chamber is our park emergency brake. Here we've got a coiled spring that is compressed, right? And the energy that is stored in that spring as it would be released would expand out, push the piston down. We've got a relay piston here. We've got a 30 square inch surface of this piston here, pushing down, push against the relay plate. And here, this relay piston would come through the brake chamber into the service brake chamber and push that service brake piston out to apply the brakes.